Let's take a look at braking distance formula again. So we took a look at this earlier, and we have the distance a car travels in feet is equal to the speed, its initial speed when it started braking, squared, and then divided by this crazy factor down here. We have twice the acceleration due to gravity, and then we have a friction value, and then we have the road grade here. So in this case, we're given the acceleration due to gravity is always about the same. It varies slightly by sea level, but we're just going to go with this 32.2 feet per second per second. So feet per second is speed, and if we divide by seconds again, we have a change in speed, which is acceleration. So that's that second per second there. And then we're going to go with a road grade of about 2% for this one right here. And so we want to set up a formula where we can check different friction coefficients, different tires on icy roads or wet roads or dry roads or gravel roads and so on. So we just want to plug this in and see what happens. So we're going to get a new formula here. So let's plug some stuff in. We'll have D equals velocity here. We're just going to leave that. And then down below, we're going to have twice that 32.2. And then we don't know friction yet. We're going to plug those values in. And we do know the road grade. That's 0.02, 2%. And then I'm missing one piece of information. Let's go back to the problem and check. Let's see. There's the road grade. I was given a velocity of 72, and you might have a different velocity. Okay, so 72 miles per hour, but I need to make that into feet per second to use in this formula, so always double check. Do you have the right units when you're given information or when you're outputting information? So we got to fix that. All right. So we also know that the velocity is 72, and that's miles per hour, and I'm going to write it like that so I can convert to feet per second. So I need to get rid of hours, so that's going to have to go in the top, and I want to convert from hours to seconds, so that goes underneath. And then there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 means 3,600. Pen's lagging a little. Pushing the wrong buttons. There we go. Per one. And then hopefully you remember that, let's see, miles is in the top. To get rid of it, we put it in the bottom. Put feet up here, and there's 5,280 feet in a mile. So this tells me that if I multiply by 5,280 and then I divide by 3,600, then that will give me a value here in feet per second instead of miles per hour. So now we need a calculator. And I have a spreadsheet here to help me out. All right, so initially we had V equals 72 miles per hour. And we are going to convert that to a new value for V equals, let's take that 72, multiply by 5280, and remember, a spreadsheet is a calculator, and I can type those numbers in here as long as I start with an equals. And so it should be 105 feet per second. So, and if you want to do calculations, the number has to be in one cell, and what it means has to be in another, otherwise you can't calculate that. So if I had tried to write 72 miles per hour in the same cell and then calculate with it, the computer's not going to recognize that as a number because it's got letters in it too. So just check. If I tried to calculate with that, all hell is going to break loose. So is it 5280 divided by 3,600? And the computer's like, what? I don't know what to do with that. You got text. How do I multiply by MPH? It's just words. So the computer got confused. So again, numbers go in a cell, and what they mean go in another cell. So I have three cells trying to describe what I'm doing here, and these two cells work with the numbers and the calculations. And double check I did it right. 5280 divided by 3600. Does that really match my notes? Yep. All right. So that would be, again, oops, come here, show me the value. And if you don't like using a spreadsheet, you can always whip out a regular calculator by just typing your numbers in here. And that's fine too. So 105.6. And that is feet per second. And I need the feet per second to match the feet per second up there. Otherwise, there's all different kinds of units and everything goes to hell. So fixing the top of this formula, ooh, that's a big eraser. I can plug in the value of V, which is 105.6, and then I have to square it. So I'm still not done cleaning this up. So I just plug the numbers in there. And now we just clean it up a little bit to make it more usable. So I want to square the 105.6. I want to multiply those numbers together and see what I get. So let's clean it up some more. Calculator. So I'm just going to make a note that the next thing I want is V raised to the second power. So I'm just telling myself what I'm doing if I look back at it later. And equals, I can just click on the number above and then raise that to the second power. Remember, you have to have equals first if you're on a spreadsheet. Otherwise, just use your calculator. And so I have what? 11,151.36. So let's make a note of that. So you come down here. That was just a side calculation. So now I've got D equals 11,151.36. Is that 105 squared? And then 2 times 32, that would be 64.4 times parentheses F plus that 0.02. And I think I'm going to take this one step farther by distributing that 64.4 in here. So then I'll get D equals 11,151.36. So we got a little bit of work to clean up still. 64.4 times F is just 64.4 F plus whatever 64.4 times 0.02 is. All right, so I'm not sure what to call this yet, but let's do the calculation. So 64.4 times 0.02, and since those numbers aren't already in my sheet, I have to type them because I got to type those right. 1.288. All right, and what was that? That was the 2 times little g times big G, I think is what that works out to be. 1.288. All right. So this is now my simplified formula. I can't do much more with it. I can't carry out this addition any further because this one has an F and that one does not. They're not like terms. And I can't do the division because I would have to do the addition before the division. So the only way I can clean this up further is if I plug in a number for F, which I'm about to do over here. Okay, so for example, to get this number right here for the distance, I'm going to take my 11,151.36 and divide that by, and I'm going to use parentheses because this is a big denominator. This is essentially parentheses even though they weren't written because of the big fraction bar. And then it's going to be 64.4 times the 0.3, then plus the 1.288. And once I plug that into my calculator, I know what to type into this box here. So calculator or spreadsheet, and so here I have it set up to do the distances. And I'm just going to move these guys over, make it a little more readable maybe. All right, so I'm going to go equals and 11151.36 divided by parentheses 64.4 times, and here I'm just going to click on the friction number, plus the 1.288. And so it tells me the first one's about 541.1 rounded. And then I'm just going to repeat that calculation with a new value each time here. So that's the F here. And a spreadsheet's a nice way to repeat a calculation. Once I type the formula in there that says, hey, just use those numbers, but the number to the left there, then I can just fill that down. So if I type that right, I should just be able to fill it down. Okay, so the next one I believe is about 333. Just to double check that, I could retype it manually again. 11151.36. Divide by parentheses, because anytime you have a complicated numerator or denominator, you got to put it in parentheses. Please remember that. Times that 0.5 over there, plus the 1.288. And if I did it right, it should be, yeah, still about 333. So I got it right this time, and I was just able to fill it down if I got it right. Otherwise, just keep plugging in your calculator carefully. So we could do it up here too. Double check. 11151.36 divide by parentheses, and you just need to be a master of your calculator. Every calculator is a tiny bit different in the way it functions. Times, let's do the next number just to compare, 0.7 plus the 1.288, and you should be writing this on paper in addition to plugging it into a calculator. So that says 240.5-ish, and back here we've got the same exact number. Okay, so I'm doing it right. All right, so it's about 333-ish. If it said round to the nearest tenth, those 9s round to a 0 and a 3 there. So this one here is 333.0, and this one was 240.5 to the nearest tenth. And oh good, I read the instructions right. It did say to the nearest tenth. Sometimes I'm not good at reading the fine print. I don't know about you. And then when I plug in the 0.9, I get 188.2. There we go, 188.2. So just a couple of notes on what's going on here. The friction is increasing. So just like what does it mean to have a friction of 0.3 or 0.5, 0.7 or 0.9? So the 0.3, if F equals about 0.3, I would bet that's an icy road. If F is equal to 0.5, that's probably like a very wet road. 0.7, well, maybe that's like riding on gravel road. And then 0.9 is probably like dry pavement. Okay, so the higher the friction, that means the better your tires are gripping when you try to stop. The lower the friction means it's pretty slick. And so what we see is the higher the friction is, as the friction increases, right, those numbers are going up. The distance it takes to stop is going down, right? We have better grip. So that column is going down as this column goes up. So that's just a good thing to note there. And you'll have a homework question about that. So I just wanted to demonstrate cleaning up a formula so that you can then use it repeatedly. Using a formula repeatedly is a magnificent application for a spreadsheet, but there's nothing wrong with a regular scientific calculator. So I hope this was helpful. Take care. Do good math. Bye-bye.